Okay, so we're going to look at three different cases. You can charge a single sphere by induction. Okay, so you have a neutral sphere. So if you look at this sphere, it's made of two parts. There's the sphere, then there is this support. So that support should always be made of an insulator. An insulator is a material that does not conduct electricity. The reason is we don't want electrons to misbehave by passing through the the insulator. It should not affect the results of the experiment. So now if you get a positive charged balloon, I'll explain why it is to make the balloon positively charged, but you get a positively charged balloon, or maybe that's not necessary, but just concentrate on what I'm about to say. So if you get a positively charged balloon, okay, you bring it close to the sphere, but make sure that they don't meet, just close. Okay, so the electrons in here, before anything, they are like this. Okay, they are just randomly distributed and they're all balanced. Okay, electrons and the protons. Okay, so now when you bring this positive, since unlike charges attract, the negative, the electrons are going to move to the left, leaving the right positive. So we're going to have this distribution where we have the negative on the left and the positive on the right. Okay, make sure that they're not touching, because if you touch, depending on the conductivity of this, these electrons can even jump into here. So if you want to charge this sphere to make it negative, the next step that you do is you ground the sphere. Okay, before you remove this, you ground the sphere. Okay, what does it mean to ground? You connect a wire and you connect it to the ground, or you touch it and you make sure that you step on the ground. When that happens, there is going to be a movement of electrons. So the ground has a lot of electrons and it attracts electrons. That's what the ground is. It has lots of electrons and attracts electrons. So when you ground this wire, so electrons are going to come. Let me say that again. When you ground this wire, okay, so since it has positive charge here, so the positive charge will attract the negative charge from the ground. So the negative charge will come into here, making this side neutral. Okay, the negative electrons will come from the ground to mix with these positive charges here, making the right side neutral. So if the right side is neutral, then we have a situation of just having more negative electrons, and at the end of the day, when you remove this and this, your sphere just becomes negative. Okay, so if you watch the step, first is neutral, make sure that it has an insulator. Second, you bring a positive recharged material, so it is a distribution of charge, negative on the left, positive on the right. Okay, then when you ground, what's going to happen is negative electrons from the ground will go into the sphere to balance with the positive ones. Okay, therefore when it balances, it means there's going to be neutral on the right, then on the left we have excess negative charge, and when you remove these things, meaning that there will be more electrons, hence it will be negatively charged. Okay, that's the first situation. Okay, then what if you want to charge this metal sphere positive? You want it to be positive. So here are the steps. Okay, so the first thing you do is, again, you know the rules. Okay, then you have to bring a negatively charged material. When you do that, the positive one is going to be on the left, the negative on the right. Okay, remember, only electrons move, the positive charge do not move. Okay, the positive charge shows the absence of electrons. Okay, then the negative charge shows the presence of electrons, and it is electrons that move and they're negatively charged. So when now you ground this, these electrons will move to the ground. Electrons always want to go to the ground. Electrons always want to go to the ground. Okay, if this was positive this side, then you take it to the ground, then electrons would come from the ground and to mix with the positive charge. But if it's negative, the negative charges will go out to the ground, okay, leaving just the positive charges. Okay, so if you take out this, then you have a positively charged sphere. That's how to charge a sphere positively. Okay, let's look at scenario number 3. Scenario number 3 involves charging two spheres at a go. Okay, so when you want to charge two metal spheres, so you put them together like this. Okay, make sure that they are all on insulated stands. So you can bring a positively charged material. So what's going to happen is, if these two spheres are touching, okay, the electrons will move from both of the spheres to the side that is close to the positive one, okay, making one side negative. Then the far end will be positive. Okay, after doing that, don't remove this. Okay, you can separate the two spheres. Okay, by pushing this one out. When you do that, this one remain with positive charge and this one with negative charge. That's when you can take out this. Hence you have a negative charge sphere and a positive charge sphere. Okay, so that is charging by induction. So anyway, it's the same concept here, but this time we want the one on the left to be positive. So in that case, you have to use a negatively charged material so that the electrons are pushed away to here, because like charges repel. So electrons will be pushed away to here, meaning leaving this side positive. Okay, so that like charges attract. Okay, and after that you can push away this, and after that you can take away this. Okay, you have two charged spheres, oppositely charged spheres. I'm failing to speak. Next, we look at the concept of charging by friction. So charging by friction is where we have one material, then you rub it with another material, then electrons can go either here or here, depending on which one has more affinity for electrons, the one with the more attraction for electrons. Okay, so in that case, the list here shows the affinity for electrons. The materials on top are more attracted to electrons than the ones on the bottom. Though the ones that tend to come are rubber, which can come in form of a balloon. A balloon is made of rubber. A shoe is made of rubber, but most of the time they like to bring a balloon. Okay, wood. Okay, human skin, silk, and fur. Not cat fur specifically, they just say fur. Also wool and glass. Okay, so these ones, the ones on top have a high affinity for electrons. What that means is, if you get this and this, okay, so you get this, which is wood, and you get this, which is maybe balloon, rubber. So this has more attraction, so electrons will go this side. Okay, leaving this more positive and this becoming more negative. Okay, so at the end of, if you are rubbing this against each other, this will be negative, this one is going to be positive. A famous and interesting example is when you get a balloon, you rub it in your hair. Okay, when you do that, since balloon is rubber, air it's fair, so electrons will move from your hair to the balloon. Your hair is going to be positively charged, while the balloon is going to be negatively charged. So at first we looked at induction, then we looked at friction. Now we're looking at conduction. Conduction is where you put the two materials together. Okay, so if you have a sphere like this, you want it to be negatively charged. You want it to be yes, positively charged, not negatively, positively charged. You just get any charged thing, then you put them close like this. Okay, so it's the same as friction. Okay, but here you have to make sure that the two conducting, there is to conduct, okay, so that you don't need to rub. Okay, so when you put them like this, so if this is positive, all electrons will go into this, making this neutral, leaving this positively charged because it has lost electrons. Okay, again, if you want to charge this negative, you do the opposite. You get a negatively charged thing, you put it here. Okay, so what's going to happen, electrons are going to go into here, making this negatively charged. Okay, so long as these two have got different affinity for electrons, actually not even affinity, so long as this one is positively charged, or I mean so long as one of these is, because we're assuming this one is a neutral, okay, meaning it is not charged. So if this one is positively charged, it will turn this one into positive. Okay, if this one is negatively charged, it will turn it will turn this one into a negative. So that's everything.